So in last video we have seen about the concept of straight lines. Now in this session we will see about the problems on straight lines. So first in exercise 11.2 show that the three lines with the direction cosines are mutually perpendicular. Whenever we say that two lines are mutually perpendicular, then sum of the product of direction ratios is equals to 0. That is a1 a2 plus b1 b2 plus c1 c2 is equals to 0. When DCs are given, L1 into L2 plus M1 into M2 plus N1 into N2 is equals to 0. So that is the condition for the perpendicularity. So here it is given direction cosines of three lines are 12 by 13, minus 3 by 13, minus 4 by 13. Next line is 4 by 13, 12 by 13, 3 by 13. And last line DCs are 3 by 13, minus 4 by 13, 12 by 13. You have to show that these three lines are mutually perpendicular. To show that they are mutually perpendicular, you have to show that, suppose if it is L1, M1, N1, L2, M2, N2, and here it is L3, M3, N3. To show that mutually perpendicular, show that first two lines are perpendicular to each other. Show that second and third are mutually perpendicular to each other. Then first and third are mutually perpendicular to each other. Let me take this one as line 1, line 2, line 3. In these three cases are there. So I will do one case, rest of the two cases you have to do it. To show L1 is perpendicular to L2. To show L1 is perpendicular to L2, we show that L1, L2, am I right? A1 into A2 plus B1 into B2 plus C1 into C2 is equals to 0 plus M1 into M2 plus N1 into N2 is equals to 0. You have to show this. So consider LHS. LHS is equals to L1 L2 plus M1 M2 plus N1 N2, which is equals to, substitute the values, 12 by 13 into 4 by 13 plus minus 3 by 13 into 12 by 13 plus minus 4 by 13 into 3 by 13, which is equals to 12 fours, 48 by 169 minus 36 by 169 minus 12 by 169, which is equals to 48 minus 48 by 169, which is equals to 0. Therefore, L1 is perpendicular to L2. Second one, to show L2 is perpendicular to L3. To show L2 is perpendicular to L3. Then what do you have to show? To show this one, we show L2, L3 plus M2, M3 plus N2, N3 is equals to 0. We are showing the sum of the product of direction cosines is equals to 0. Consider LHS. Consider LHS. That is L2 L3 plus M2 M3 plus N2 N3. Substitute the values and find out. Then third one is to show L3 is perpendicular to L1. We show that L3 into L1 plus M3 into M1 plus N3 into M1 is equals to 0. Consider LHS, which is equals to L3L1 plus M3N1 plus N3N1. Substitute the values and show that it is 0. Therefore, the given lines are mutually perpendicular to each other. So, I hope this is a simple concept. You can complete that one. Next, second one is show that the line passing through the points is perpendicular to line passing through 2 points. You have to show that these two lines are perpendicular to each other. How do you show these two lines are perpendicular? Same process. Find the direction ratios. So, first find out direction ratios of line joining points. Direction ratios of line joining points. You can take it as A of 1, minus 1, 2 and B of 3, 4, minus 2. Or how do you find the direction ratios? 3 minus 1, 4 minus of minus 1 minus 2 minus 2. That is 2, 5 minus 4. You can name it as A1, B1, C1 because these are the direction ratios. And direction ratios of line joining points C of 0, 3, 2 and D of 3, 5, 6 are 3 minus 0, 5 minus 3, 6 minus 2. That is 3, 2, 4. You can name it as A2, B2, C2. Now you know the direction ratios of both the lines. To show that line AB is perpendicular to line CD. To show that AB is perpendicular to CD, we show that A1, A2 plus B1, B2 plus C1, C2 is equals to 0. Consider LHS. LHS is equals to A1, A2 plus B1, B2 plus C1, C2. That is equals to, substitute the values. This is 2 into 3 plus B1 is 5 into 2 plus C1 is minus 4 into 4. This is 6 plus 10 minus 16. 16 minus 16 is equals to 0, which is equals to RHS. Therefore, the line EB is perpendicular to line CD. I hope these are all very simple concepts. You find the direction ratios. To show the perpendicularity, sum of the products of the DRs is equals to 0. To show the parallelism, A1 by A2 is equals to B1 by B2 is equals to C1 by C2. That's all only. Next, come to the third question. Show that the line through the points. So here same thing, line through the points or there's a parallel to the another line through the points. You have to show that two lines are parallel. So the third one is DRs of the line joining points. DRs of the line joining points are A of third one, A of 4, 7, 8 and 2, 3, 4. Then DRs are 2 minus 4, 3 minus 7, 4 minus 8. So that is minus 2, minus 4, minus 4, A1, B1, C1. Then Another line is C of -1, -2, 1 and D of 1, 2, 5 are 1 plus 1, 2 plus 2, 5 minus 1. That is 2, 4, 4. You can name it as A2, B2, C2. To show that AB is parallel to CD, we have to show that A1 by A2 is equals to B1 by B2 is equals to C1 by C2. Just to consider separately what is A1 by A2, what is B1 by B2, what is C1 by C2. So A1 by A2 is equals to -2 by 2 is equals to -1. B1 by B2 is equals to -4 by 4 is equals to -1. C1 by C2 is equals to -4 by 4 is equals to -1. Therefore, A1 by A2 is equals to B1 by B2 is equals to C1 by C2. When the ratios of the corresponding components are in the same proportion, then those two lines are parallel. Therefore, AB is parallel to CD. Next problem is find the equation of a line passing through the point and parallel to. When passing through the point and parallel vector is given, we know directly what is the formula. So fourth one, given line passes through a point 1, 2, 3 whose position vector is. We know how to write the position vector of the point. Position vector of this point is nothing but A is equals to I plus 2j plus 3k. Just to recall the vectors, how do you write the position vector of a point? So in the last session also I have explained how to write the position vector of the given point. A and parallel to vector B is equals to 3i plus 2j minus 2k. Then the equation of a line is R is equals to A plus lambda B. That is the formula. Directly you can remember the formula. R is equals to A plus lambda B. That is R is equals to A is I plus 2j plus 3k plus lambda into B is 3i plus 2j minus 2k. That's all, which is in vector form. If at all you want Cartesian form, you can write Cartesian form, otherwise you can leave. So in Cartesian form, x minus x1 by a is equals to y minus y1 by b is equals to z minus z1 by c. What are A, B, C? They are the drs of the parallel vector. So these are the drs of the parallel vector. And x1, y1, z1 are nothing but coordinates of the point. So just to substitute it, x minus 1 is equals to y minus 2 is equals to z minus 3 by drs of the parallel vector 3, 2, minus 2. So you can directly also write the Cartesian form. Next, come to fifth one. Find the equation of the line in vector and Cartesian form that passes through the point with the position vector and is in the direction. Same problem. Same problem, there is no change at all. So fifth one, given line passes through a point whose position vector is is given as 2i minus j plus 4k, and in the direction means parallel, and in the direction b is equals to I plus 2j minus k. So that is, passing through a point is given, direction is given. Therefore equation of a line, then equation of a line is R is equals to A plus lambda b, which implies R is equals to 2i minus j plus 4k plus lambda into b is I plus 2j minus k. So which is vector form. Which is in vector form. If at all you wanted to do in the Cartesian form, so what you have to do? Cartesian form, either you can apply the formula, or from this also directly you can extract. How it will be? Substitute what is R? R is nothing but what? xi plus yj plus zk is equals to 2i minus j plus 4k plus lambda into I plus 2j minus k. Bring this side, this will become x minus 2 into I plus y plus 1 into j plus z minus 4 into k is equals to lambda I plus 2 lambda j minus lambda k. When two vectors are equal, their corresponding components are equal. X minus 2 is equals to lambda, y plus 1 is equals to 2 lambda, z minus 4 is equals to minus lambda. Now take the ratios, that is x minus 2 by 1 is equals to lambda, is equals to y plus 1 by 2 is equals to lambda, is equals to z minus 4 by minus 1 is equals to lambda, is nothing but Cartesian form. Either you can extract, or like this you can write the formula. Whichever is convenient for you, you can follow this method. Next, sixth one. Find the equation of the line which passes through the point. So point is given and parallel to the given line. It is parallel, vector is not given, parallel to the another line. When it is given parallel to the another line, parallel vector is nothing but parallel vector of the other line. So once again I am repeating, parallel vector is not given, but line is parallel to another line. That means their parallel vectors are same only. Now given line is x plus 3 by 3 is equals to y minus 4 by 5 is equals to z plus 8 by 6. You can name it as 1, whose drs of parallel vector are 3, 5, 6. These are the drs of the parallel vectors 3, 5, 6. Next, also given that required line passes through minus 2, 4, minus 5 and parallel to line 1. Therefore, the equation of a line. The equation of a line is x minus x1 by a is equals to y minus y1 by b is equals to z minus z1 by c. So since it is passing through the point is nothing but x1 y1 z1. Since the line is parallel to this, so these are nothing but the direction ratios of the parallel vector. So which implies x minus of minus 2 is equals to y minus 4 z minus of minus 5 by a is nothing but 3, b is nothing but 5, is nothing but c, which implies x plus 2 by 3 is equals to y minus 4 by 5 is equals to z plus 5 by 6. Coming to seventh problem. The Cartesian equation, seventh one, Cartesian equation is given. Cartesian equation of a line is x minus 5 by 3 is equals to y plus 4 by 7 is equals to z minus 6 by 2. Write it in a vector form. What is the vector form? R is equals to a plus lambda b. That means R means is nothing but xi plus yj plus zk. This only thing you have to do is what is the value of x, what is the value of y, what is the value of z. You have to find out, that's all only. You take is equals to lambda say, which implies x minus 5 by 3 is equals to lambda, y plus 4 by 7 is equals to lambda, z minus 6 by 2 is equals to lambda. Why? We have to find out what is x, what is y, what is z. Which implies x minus 5 is equals to 3 lambda, y plus 4 is equals to 7 lambda, z minus 6 is equals to 2 lambda. Which implies x is equals to 5 plus 3 lambda, y is equals to minus 4 plus 7 lambda, z is equals to 6 plus 2 lambda. Therefore, R is equals to, what is R? Xi plus yj plus zk. We can do in the different forms. I am following the easiest way. R is equals to xi plus yj plus zk. Just to substitute it, which implies R is equals to 5 plus 3 lambda into I plus y is minus 4 plus 7 lambda into j plus z is 6 plus 2 lambda into k, which implies R is equals to, now I will take only non-lambda terms, 5i minus 4j plus 6k plus lambda into, now lambda terms, 3i plus 7j plus 2k. This is the easiest way of doing, that is transforming Cartesian into vector form. Next is find the vector and Cartesian equations of the line passes through origin, and one more point, 2 points are given. So eighth one is given that line passes through origin 0, 0, 0 and another point 5, minus 2, 3, whose position vectors are A is equals to 0i plus 0j plus 0k and B is equals to 5i minus 2j plus 3k. I hope it is clear, children. 2 points are given. I am writing their position vectors. Then what is the equation of a line passing through two forms? The equation of a line passing through 2 points. Passing through 2 points is first one in vector form. In vector form, R is equals to A plus lambda into B minus A, which implies R is equals to A is nothing but 0 vector. So this is 0 vector origin plus lambda into B minus A. 5i minus 2j plus 3k minus of 0i 0j 0k. That is R is equals to lambda into 5i minus 2j plus 3k. This is the vector form. What is the Cartesian form? Cartesian form x minus x1 by x2 minus x1 is equals to y minus y1 by y2 minus y1 z minus z1 by z2 minus z1. Just substitute the values x1 y1 z1 x2 y2 z2, which implies x minus 0 by 5 minus 0 is equals to y minus 0 by minus 2 minus 0. This is z minus 0 by 3 minus 0, which implies x by 5 is equals to y by minus 2 is equals to z by 3. So this is very simple passing through 2 points. Next, come to 9th question. 9th is same as 8th one, so you take it as a homework. There is no change, passing through 2 points. Next, come to 10th one. You have to find out angle between 2 pairs of lines. So in 10th, first one I will do, second one you do it. Given R is equals to 2i minus 5j plus k plus lambda into 3i plus 2j plus 6k, which is of the form R is equals to a1 plus lambda b1. So the given line is of the form R is equals to a1 plus lambda b1, where a is equals to 2i minus 5j plus k and b1 is equals to 3i plus 2j plus 6k. This is about the first line. And second line, R is equals to 7i minus 6k plus mu into I minus I plus 2j plus 2k, which is of the form R is equals to a2 plus mu b2, where a2 is equals to 7i minus 6k and b2 is equals to I plus 2j plus 2k. Now from the given lines, what is A1, B1, what is A2, B2, everything we have traced out. Now how do you find the angle? So angle between two lines, is, how are you finding? Cos theta is equals to B1 dot B2 by magnitude of B1 into magnitude of B2, which is equals to B1 is 3i plus 2j plus 6k dot B2 is I plus 2j plus 2k by under root B1, magnitude of B1 3 square plus 2 square plus 6 square, B2 is 1 square plus 2 square plus 2 square, which is equals to 3 ones are 3 plus 2 twos are 4 plus 6 twos are 12 by this is 36, 40, 49, 7, 4 plus 4 plus 1, 3 is nothing but 19 by 21. Is it right? So 7 plus 12, 19 by 21. Therefore, theta is equals to cos inverse of 19 by 21. Only thing what you have to do is you have to trace out what is B1, what is B2, just substituting in the formula. Now see 11th one. Equations are given in terms of Cartesian form. Previous problem was in vector form, now it is in Cartesian form. When it is in Cartesian form, x minus x1 by a1 is equals to y minus y1 by b1 is equals to z minus z1 by c1. Therefore, the drs of the first line are 2, 5, minus 3. And in the same way, the drs of the second line are minus 1, 8, 4. So this is nothing but a1, b1, c1, and here it is a2, b2, c2. Now what you have to do? You have to find out the angle between the two lines. So angle between two lines we can find by using the formula is cos theta is equals to a1 into a2 plus b1 into b2 plus c1 into c2 by under root a1 square plus b1 square plus c1 square into under root a2 square plus b2 square plus c2 square. Just to substitute the values, that's all. 2 into minus 1 plus 5 into 8 plus minus 3 into 4 by under root 2 square plus 5 square plus minus 3 square, and here it is minus 1 square plus 8 square plus 4 square, which is equals to minus 2 plus 40 minus 12 by under root, this is 25 plus 9, 34 plus 4, 38 into, this is 64 plus 16, 80, 81. That is equals to, now 40 minus 14, 26 by root 38 into 9. Therefore, theta is equals to cos inverse of whatever is coming, 26 by 3 into, 9 into root 38. Just to simplify and write off. Next, coming to the next problem, 12th one. Find the values of P. Find the values of P so that the given lines are at right angles. When they are already in right angles, means sum of the product of drs is equals to 0. Only thing is what? You have to trace out what are the drs. This is not in the standard format. This is not x minus x1, 1 minus x. So I will change this x minus 1 by minus 3. And here, if I take 7 as common, this will be y minus 2 by 2p by 7. 7 I am bringing here. 2p by 7 is equals to z minus 3 by 2. In the same way, here, this is not in the standard format. If I take minus 7, this will be x minus 1, 3p by minus 7 is equals to y minus 5 by 1 is equals to z minus 6 by minus 5. I hope you are understanding this. When you take minus 7 as common, this will be x minus 1. So that minus 7 I am bringing downside. Therefore, drs of L1 are not this. These are the drs after bringing it to standard form. Or drs of L1 are minus 3, 2p by 7, 2. And drs of L2 are 3p by minus 7, 1, minus 5. Now this is nothing but a1, b1, c1, a2, b2, c2. Just which implies, since they are already perpendicular, sum of the product is equals to 0. That is minus 3 into 3p by minus 7 plus 2p by 7 into 1 plus 2 into minus 5 is equals to 0. Now from this, calculate this and find what is the value of p. That's all about 12th question. Next is 13th one. Show that the lines are perpendicular to each other. So you know already how to show they are perpendicular to each other. Find the drs of the first line, find the drs of the second line, so that you have to show a1 a2 plus b1 b2 plus c1 c2 is equals to 0. Already this model we have done it. Next, 14, 15, 16, 17 all are same, there is no change. Find the shortest distance. So if it is given vector form, it is well and good. If it is given in scalar form, that is in Cartesian form, you will convert into vector form and do it. That's all only. You know how to do Cartesian form to vector form also. In this exercise we have done that also. So 14.1, one problem, let me do it. 14.1, given lines R is equals to I plus 2j plus k plus lambda into I minus j plus k, which is of the form R is equals to a1 plus lambda b1, where a1 is equals to I plus 2j plus k and b1 is equals to I minus j plus k. Next, and another line R is equals to, it is given 2I minus j minus k plus mu into 2I plus j plus 2k, which is of the form R is equals to a2 plus mu into b2, where a2 is equals to 2I minus j minus k and b2 is equals to 2I plus j plus 2k. Now the given equations of lines, we have traced what is a1, what is b1, what is a2, what is b2. Now we know what is the formula of the shortest distance. D is equals to a2 minus a1 dot b1 cross b2 by magnitude of b1 cross b2. So find out step by step. First one, a2 minus a1, which is equals to 2I minus j minus k minus of a1 is I plus 2j plus k. 2I minus I is I minus j minus 2j minus 3j minus k minus 2k. Second part, find out b1 cross b2, that is equals to I, J, K, B1 is nothing but 1 minus 1, 1 and B2 is equals to 2, 1, 2. So I am finding B1 cross B2 separately, that is I into minus 2 minus 1 minus J into 2 minus 2 plus K into 1 plus 2. This is minus 3I plus 3K. Then what else is required? Third one, magnitude of B1 cross B2, that is under root minus 3 whole square plus 3 square is root 18. You can write it as 3 root 2. Therefore, shortest distance D is equals to modulus of A2 minus A1 dot B1 cross B2 by magnitude of B1 cross B2, that is equals to A2 minus A1 is I minus 3J minus 2K dot minus 3I plus 3K by magnitude of B1 cross B2 is 3 root 2, which is equals to 1 into minus 3 plus 0, that is 0 minus 2 into minus 3 minus 6 by 3 root 2, which is equals to minus 9 by 3 root 2. Since it is modulus, this is nothing but 3 by root 2 units. When it is given in Cartesian form, convert into vector form. A is nothing but A1 is nothing but x1i plus y1j plus z1k. B1 is here A1i plus B1i plus C1j. Just transform into vector, then follow the same thing. So I hope you have understood this, how to find shortest distance between two lines. So with this I will stop. Then in the next session we will speak about the planes.